Hello matriculants, and welcome to another video, and we're just going to tie the knots in Euclidean geometry by doing the February March 2018 paper 2. Again, we're just going to put more emphasis on the approach to viewing these questions and how to work them out, and then our next stop will be trigonometry, at the end of which we will just do one complete paper now to put everything together. Alright, let's go and have a look what is in there. Okay, this is question 7. Alright, now question 7 says in the diagram PQRT is a cyclic quadrilateral. Again, that statement, cyclic, it's a giveaway because one would have to see that by themselves because these vertices are at circumference. Anyway, that is as easy as they're making it. Okay, and they're saying that PT and TR are equal, and we can see there that the side PT equals the side TR. And then of course, if we just pause there and say what is the significance of those sides being equal, we know that equal sides subtend equal angles at circumference. Equal chords, not sides, sorry. They subtend equal angles. Okay, let's just do this in double lines so that it can be visible. So that side equals that side, not side, angle. Yeah, the English. So that is the story there. It just says angle Q1 equals angle Q2. Why? These are angles subtended by equal chords in the same circle. Again, if these were two different circles, we'll be talking a different story. Alright? Good. Alright, fine. Again, let's read PT and QR. Okay, we can see them are produced to meet at S. That means PTS and QRS are straight lines, right? And if these are straight lines, now the emphasis is that, well, this now puts us in a very good position because we know now that PQRT being a cyclic quad, now we have this situation here where we know now angle P equals angle R1. This is an exterior angle of a cyclic quad which will be equal to the opposite interior angle of a cyclic quad. Okay, and the same applies. Q1 plus Q2 will essentially be equal to T1. Again, we have a situation here. So maybe let's shade this whole angle. As much as we know the blue lines indicate that the two are equal, but together they form this brown angle, and this brown angle will equal to yet another brown angle, which is T1. We're just going to shade that. That again is an exterior angle of a cyclic quad. Okay, not a problem. Alright, so this so far is the best we can do. Then of course we know that angle P plus angle R2, they are supplementary. These are opposite angles of a cyclic quad, PQRT. Alright, and we are told now TQ is drawn, which is a diagonal of that cyclic quad, such that SQP SQP, this whole angle is 70 degrees. If this whole angle is 70 degrees, this tells us that is also 70 degrees, right? Yes, that should also be equals to 70 degrees because they are equal. That's an exterior angle of a cyclic quad. Alright. Anyway, this is the very best we can do at this point in time. And of course, we know when we divide that 70 by 2, let's just take a better color. When we divide that 70 by 2, because these two are equal, so 70 divided by 2 for each, we know now that each one is 35 degrees. So I think these are the calculations we can do, and then of course the same applies for the other one. No problem. What is there? Let's see what questions are they asking us to do. Great. We now are told, okay, calculate with reasons the size of T1. T1 is 70 degrees. It's an opposite angle. It's an exterior angle of a cyclic quad. Angle Q1, okay, Q1 equals Q2, angle subtended by equal chords. Therefore, 70 divided by 2 gives each one of them. So Q1 will be 35 degrees. Great. And then we are told it is further given that PQ is parallel to TR. Okay, let's indicate that. If that's the story right there, so what is the implication thereof? Okay, so if this is the case, now we know for a fact that that angle Q1, right, will equal angle Q2. These are alternate angles, okay, with these two lines parallel cut by this transversal line TQ. And if this is the case, it also means that that angle over here equals that angle up there, angle P. Why? Because now these are corresponding angles. So this is the new situation now. So be careful not to mix 7.1 and this new information, because in 7.1 this is not the case. It only comes in 7.2. Alright. So the same also here. It tells us now that the 70 over there is going to be the 70 over here. So again, now this is the story in 7.2. Again, I think we overly explained this situation, but I hope you understand now. You'll just focus on the video. So this is the situation that this creates. And as a result, it now says, okay, this side will be equal to that side because those two angles are equal. And the same thing applies. SQ and PQ will be equal because those base angles are equal, making this isosceles triangle. Okay, let's make 3 because there's already 2's there. Great stuff. Okay, maybe we overly explained this. Okay, fine. The question says calculate with reason the size of T2. Angle T2 is said is going to alternate with Q1, so it's going to be 35 degrees. Great. And then it says prove that TR over TS, TR over TS, okay, equals RQ over RS. Alright, fine, not a problem. We will see how to work on that. It's just 2 marks, so it shouldn't be a big deal. So let's quickly get to answering before we lose a large amount of time. Okay. Question 8. So these are easy questions, folks. There will always be them in the first portion of this Euclidean section. So make sure no marks get lost in here. So this is 7 now. Okay, it's no longer question 8. Alright. Question 7, we said in 7.1, all the brown angles were not there. So in 7.1, we only have a cyclic quad and angle Q, 1 plus 2, and that's all we have. So don't mix up anything. There were no parallel lines there, so forget about them for this section. So we have now 7.1.1, and we are told calculate the size of angle T1 with reasons. So we don't mind. We know that angle T1 equals angle Q 1 plus angle Q2, if you will. You can write it like that, or you can just say PQR or PQS. It's up to you. The way they said it, it's SQP. So either way, it's fine. So what is the story there? This is an exterior angle of cyclic quad. I'm not going to mention which one it is. It's quite evident. So this implies now that angle T1, in fact not implies, therefore here we just conclude T1 equals 70 degrees, because Q1 plus Q2 equals 70 degrees. That should be the answer. No wasting any energy there thinking too much. So the statement and the reason and the answer, they are enough for the 2 marks. Alright. Here, what did we say? We said angle T1 equals angle Q1 plus Q2. As you can see in the diagram, Q1 plus Q2 makes up PQS or SQP, if you will. So you can represent it that way or with those two small angles. They will equal angle T1. Why? This is an exterior angle. This is the opposite interior angle of a cyclic quad. So they should be equal. And that's that. So 7.1.2, what do they want? 7.1.2, we are asked, calculate the size of Q1. So we don't have a problem here. We know that Q1 plus Q2 equals 70 degrees. Right? Why are we saying this? This was given. You can see that that whole angle is 70 degrees over there, so it's given, so there's no questions about it. Alright, we have a but why? Q1 equals Q2. Now there's a very silly situation. What do we mean? These are angles subtended by equal chords. Then of course you can state, if you will, that TP or PT equals Q TR. Okay, so that was a bit of a longish reasons, but it doesn't matter. So equal chords will subtend equal angles at circumference, and we were told that PT equals TR. Okay, that was given. So that is why we're saying this. So what does this imply? It implies now that twice angle Q1, because now this is the same as angle Q1 plus angle Q1, equals 70 degrees. Okay, that's the most important. Therefore, angle Q1 equals 35 degrees. We just simply divide by 2 throughout. No questions about that. And then again, they were just giving 2 marks. Wow, this should be 3 marks, man. There's a few things, but anyway, it tells you that the mark comes here and there. They really don't worry about what they gave you. So no issues. We said again, angle Q1 plus angle Q2 gave us 70. That was given. We then had to say, okay, however, Q1 plus Q2, Q1 equal to Q2. Why? These are angles subtended by equal chords, PT and TR. That was given to us. And therefore, because we're interested in Q1, we just simply represent this sum in terms of Q1. If we were looking for Q2, we would do Q2 instead. So you just choose your battles there. and then equals 70, you divide throughout by 2, you get 35 degrees. Easy stuff. Now we're going to the part now, 7.2, where we are further given that PQ is parallel to TR. Okay, PQ is parallel to TR. Now this brings out this situation where now this angle, which was equal to that, is now also equal to that, and that angle being equal to this was initially equal to that, therefore these two are equal. So we have this isosceles triangle over here and another isosceles triangle, the big one. Alright, so, and of course these are similar triangles. If you're looking at them, this is a common angle, these angles are equal, so they are all equiangular. There's no questions about that. Okay, what is the question now? 7.2.1 says calculate with reasons the size of T2. So we want T2 now with reasons. It's just 2 marks. We don't have a problem. We have this new situation. It then tells us that we can adapt our solutions to that. 7.2.1. So we want T2. So T2, angle T2 will equal angle Q1. Alright, that is the story. So these are alternate angles. Alternate angles. And we have to specify now. We have PQ being parallel to TR. That's the new condition that we got. Therefore T2 equals 35 degrees. That's the answer. So this was fairly easy. The question again, we have the statement and the reason and the answer. So this is how probably those 2 marks are arrived at. Okay, let's quickly do this one and finish. Now it says prove that TR over TS equals RQ over RS. Now look at this, investigate this ratio or proportion. TR over TS, TR over TS. Okay, it looks like this is the triangle we're talking about, and then RQ is this side on the other one over RS over that whole side. Now what do we know? We know that TR equals TP. Alright, TR was given as TP, so TR could be the same as PT over TS, which now says, look at this triangle. We know that this line is parallel to the one side of this big triangle PSQ. And now this is where the proportionality theorem comes into the fore. So we just enjoy ourselves with this one. We don't have to do a lot of work because it's just 2 marks. So we can't be saying a lot of things. We just simply run into that. 7.2.2. We can now say in triangle. I always state this. So I prefer to start with the apex. It's SPQ. Alright, SPQ. I mean, how you name it is not really that much of a significant story here. So just name the triangle. So what do we know? We know now for a fact that we're going to start from the bottom side. We're going to say, well, we know that PT over TS, okay, equals Q RQ. Okay, they wrote RQ, so we're going to say RQ. Yeah, I'm losing a bit of my focus there. I was working last night, so I'm a bit tired. Over RS. Okay, so why are we saying that? We're saying PT over TS equals QR or RQ over RS. Why is that legal? It is because this is the proportionality theorem. Nothing special, but maybe it's very important to state that PQ is parallel to TR. Now, it now provided us this very good condition for this. Alright, we can say, however, we know that PT equals TR. Alright, that was given. Therefore, we know now that instead of writing PT, we're just going to write TR as they put it, over TS equals RQ over RS. That's the answer, because they just asked us to prove that. So always remember, these things won't come out clear that you are in this section of maths. Just be able to recognize it from what is given, and always try to look for the shortest route to the answer, because that one will have less problems, but at times there's no short route, it's just a long one. So I think that statement and the reason is very good. And then the last one, because I don't know, that was given, so it's just a matter of substituting there, which is more powerful. So that's the 2 marks. Alright folks, and then this sums up the 8 marks of this section. Okay, question 7. No problem. I hope you have enjoyed this nicely. Alright, let's just move quickly. Question 8. They are hitting us with some shortish questions. I would say shortish because they may look short, but they are not short. Alright, without wasting time. Question 8 says, in the diagram, PR is a diameter of the circle with center O. Alright, again, even if they didn't say this is a diameter, at times they won't say it. Just notice something. If you are told O is the center and you see a line coming from circumference passing through the center, going to circumference, and they are telling you it's a straight line, because the most important is to notice that this is a straight line, because if it wasn't, then you would not say it's a diameter. But a straight line passing from circumference through the center to circumference is the diameter. So being the diameter, what do we know? We know the diameter subtends a right angle at circumference. So we know now that PTR is 90 degrees. No problems. Now ST is a tangent to the circle at T, and PR produced, ST is a tangent to the circle at T and meets PR. Okay, this tangent meets PR produced at S. Okay, good. And then SPT equals X, so that's fine. We can see the representation, and S equals Y. Not a problem. But we have a tan chord situation right here, because we know the angle between the tangent and the chord equals the angle subtended by the chord in the alternate segment. Alright, so we know now that STP or PTS equals TRP, or just angle R, because it's a standalone angle. Alright, what can we do with this? I mean, there's pretty much nothing more we can do, but we can try and see if there's any links here. If one looks at this triangle, I like to always, look at things in a different manner. Look at this yellow triangle. I like this yellow color. Just have a look at the yellow triangle that I'm outlining here. PTR. So if you look at that triangle for a second, you will notice that if you extend this triangle through that straight line SP, this is an exterior angle of this triangle. And what do we know about an exterior angle of a triangle? We know that an exterior angle of a triangle equals the two opposite interior angles. Alright, great. It's always those ones, not the adjacent angle to its exterior. So you will never use the adjacent, but you look at the opposite angles. But ignore the adjacent, because these are just simple angles in a straight line. So you take it from 180. But this one is just the sum of those two angles. So if this is X, what does it tell us about angle R in terms of X? Angle R in terms of X is just simply going to be 90 degrees plus, wait, it's x minus 90 degrees. Yes. See, now I'm messing up. Alright, this is x minus 90 degrees. Because we know that the sum of these two equal x, and then when you transpose the t, it becomes x minus 90 degrees when you're solving for r. And now this tells us that that guy over there is going to be the same situation, x minus 90 degrees. Alright, good. And what can we do? Pretty much we are done, because we can still represent this one in terms of x if we like. It's going to be simply 180 degrees minus x. Even if you use three angles of a triangle, you'll still get 180 degrees minus x. Alright, wonderful, because the 90s will just eat each other up. 90 degrees minus 90 is 0, and then you remain with x, but three angles of a triangle add up to 180, so it still remains 180 minus x, so it's not a big deal, so we can see that. And then of course this is just y. If we like, we can represent this angle in terms of y and x, because it's an exterior angle of this triangle over there. Alright, not a problem. I think that's the best interpretation we can have of that. Let's see, what is the question? Determine with reasons y in terms of x. It's great. Now we know we can either use, we can choose, I'm just going to do this, we can choose to use this triangle over there, now that we know the sides to it, because it provides us a root in representing this in terms of x. But my fear though is that we may run the risk of having x minusing another x, and this becomes a problem. So it may not really work, but it's a consideration. Alright, and then we can decide we want to use this big triangle, the STR, which I think is the best approach for me, because that big triangle says, fine, we can add y and these two together, and twice of these and that from 180, we will definitely have something in terms of x. So whichever works, but let's just do it in the simplest way possible. Let's just now start working nice and easy. So this is now question 8. Okay, it's not always smooth at times, because there's just a lot of, potential confusions, but we can deal with this. We can say in triangle, we want to start drilling this from this triangle, PTR or PRT. Let's say PRT, the yellow one. Let's start there and work our way around. So what do we know there? We know for a fact that angle T, remember, when you have identified your triangle, you don't have to say PTR, because angle T in this triangle is just that angle. So it's up to you how you do this, but if you did not specify a triangle, then you have to say PTR. So we're going to say angle T equals 90 degrees, alright? Right. What is the story? It's an angle subtended by diameter. Great. You don't have to really specify which one, but if you like, you can say POR. Not a problem. That's fair enough. Okay, so these things are irritating me. Alright. Now, what do we do next? We know that our interest is to represent this triangle in terms of, this angle R in terms of x, because it becomes key to us getting a way of solving this. y in terms of x, okay? So we now know that we can simply say now, but we know that angle T, this time we have to say it, TPS equals angle T. Okay, now we have to say it because it's unfortunately going to kill us. So let's just use it here, PTR, in fact, because now it becomes a little bit complicated. It's going to be equals to PTR, all right, plus angle R, because it's a standalone triangle, angle there. What is the reason there? This is an exterior angle of triangle. Again, we don't have to specify because we know where we are. We're still there. So what does this imply? It implies now that x, because the TPS was x, equals PTR. We found out that this is 90 degrees plus angle R. Okay. Now what does this conclude? It concludes that angle R, you just transpose the 90 there, it's going to be x minus 90 degrees. Correct. That is what we wanted to know. Okay, not a problem. The next step, we're going to say however. Oh, I can go, what is that? However, what is the story? We know that STP, standard temperature and pressure, if you're doing physics, STP equals angle R. What are you talking about? It is a 10-chord theorem. I hope you guys can notice how versatile this 10-chord theorem is. It's almost everywhere in the lines of questioning in geometry. From analytical geometry to Euclidean geometry, this 10-chord theorem is like forever there. I have never seen a paper where it is not present. Anyway, not a problem. So what does this conclude for us? It concludes now that STP is going to be x minus 90 degrees. Great. That's what we wanted, because now we're going to choose our triangle now, STP. There's no need to worry about the bigger ones because we don't want this complex situation coming back. Let's just leave it here now. So we can say now this implies that in triangle, see, we're moving from triangle to triangle by linking them. Now in triangle STP, standard temperature and pressure, so we want to use triangle properties. That's why we're saying it. We know now that angle S plus angle P, now you can say the P alone here because we are now just in that triangle, plus angle T, again you can use T here alone. You don't have to say these complex angles. These are sum of 3 angles of a triangle. Easy. Oh, what am I saying? Oh my Lord, too excited because it looks simple. So these 3 should add up to 180 degrees. Great. Remember, we're looking for y, so y is angle S. This tells us now that angle S equals 180 degrees minus the sum of angle P and angle T in that triangle, not anywhere else. So what does this imply? This implies, now we substitute, S is y equals 180 degrees minus angle P. We found out that this angle P is x in there, plus, now that one, the angle T in that triangle is actually x minus 90 degrees. So we just put it there. Now what does this tell us? Okay, I can just simplify this. In fact, I don't need to do anymore. This equals, now we know 180 degrees. Wait a minute. This is going to be minus multiplied by minus, which becomes plus. So this is 180 plus 90. And you know 180 plus 90 is 270 degrees. Okay, great. 270, and then we will have a situation here where we have minus x. So this is minus 2x. Okay, so that is the story of y. When we represent y in terms of x, we get 270 degrees minus 2x. Alright, good stuff. So that is the story. Okay, great. Now we have to have a look at it quickly before we let a lot of time get lost. We don't want to waste time. Time is better conserved than wasted. So what we want to say now is, okay, fine. We said in triangle PRT, we wanted to identify that was 90 degrees, and we wanted to solve for this one. So we said PTR is 90 degrees subtended by diameter, but TPS equals PTR plus angle R. Again, that was an exterior angle of a triangle. So we worked out that angle R is now actually x minus 90 degrees as a result. We said, however, STP equals angle R. That was a 10-chord theorem. So we wanted to maneuver from that triangle to the other triangle. And indeed, it took us there because STP became x minus 90 degrees as well. And then now we just summed up all the angles of that triangle STP so that we could represent our y in terms of x. It became 270 minus 2x. So this was 6 marks. Alright, this is important because it was not directly given, and I think to get there is quite important, and in fact this is a very strong statement to put. Alright, fine. And the 10-chord theorem you will never get wrong, but this is just simply saying the same solution, so there was no calculation, no need to avoid a mark there. And then here, I mean, depends on how you like to do this, 3 angles of a triangle or correct substitution, but either way, for me, it doesn't make any sense to worry about the substitution as long as we have the right statement leading us to the right answer. So there is our 6 marks, and in fact this is the total of this question. Alright, great. No problem. I hope you have enjoyed that part. Okay, now let's keep going here. We're going backward. No problem. Let's quickly run through this one as well. So what do we have here? Alright, question 9 says, in the diagram, DEFG is a quadrilateral. Okay, that's a 4-sided figure with DE equals 45. DE as in this side. Okay, this is the length, by the way. When you see that, it just tells you about the length. Okay, so 45, and GF is 80. Again, we have a side here that equals 80. No problem. Right, now it says the diagonals GE and DF meet at H. Okay, we are told GDE equals FEG. Okay, it's indicated, so we don't have to worry. And DGE equals EFG. EFG. So again, it's represented. So they made our lives easy. So we just know, okay, we can deal with this. So what does it mean? This angle equals that angle equals that. So it tells us that these triangles, let's just highlight them. Maybe my favorite colors, the red for danger and the yellow for jealous. So I like these not so desirable things, danger and jealous. But I'm not dangerous and I'm not jealous. How funny. Ever heard of the so-called likes repel each other and unlikes attract each other? So I'm attracted by things I am not. Okay, that's crazy, but it's true. All right, so now you can see that we have this red triangle or pink triangle. I don't even know what that color is, but I will just imagine it is pink. It's red. All right, so let's look at the blue triangle. So let's see what is going on up here with these triangles. Okay, good. Now we can see that these two overlap on GE. GE is the common side to both, but they have two pairs of angles equal to each other. So even if you try to flip this triangle onto this one, that angle will lie onto this one, that angle would lie onto this one. So that means that one corresponds with that. Okay, and these are the remaining angles, so they should be equal. So these two triangles are similar. Easy, and we have a proportion, so we can determine this side because it's the common side to both. So that ratio will give us a GE squared, which is easy because then we will have the other two sides to solve the problem for us. All right, let's have a look at the questions. There's nothing much here to say, but knowing that this angle eventually, maybe let's just say this, knowing that this angle will equal that. Now these are alternate angles, so it's like a Z, so it tells you that this must be parallel to that side. Great stuff. And if that's the case, what does this quadrilateral become? A trapezium. So if you get asked, prove that this is a trapezium, you just prove that the set of two opposite sides are parallel. That's all. They don't have to be equal. Not a problem. So let's read. Give a reason why triangle DEG, okay, the blue triangle, is similar to triangle EGF, which is the pink or red triangle. Fine, they are equiangular. We are just given that, so we don't have to say anything. Calculate the length of GE. Oh, nice. That is the common side, so we just derive ratios such that this side over that equals this side over that, because this side is common to both. So if it is that common to both, it's easy now, because we know that as much as this GE for the blue triangle will correspond with the GF of the other one, but we know for a fact that the DE will correspond with the GE, so it makes life very easy. You can derive a nice ratio, then solve it. Prove that triangle DEH. Alright, where's my yellow? For jealous. So we're going to shade this guy, because it won't be nice to highlight it when there's already a highlight. So we just shade the guy and say, alright, going to give you a nice facelift, isn't it? It's always nice when you have that. Okay, and then we have to prove that that triangle is similar to triangle FGH, which is this guy here. So I'm gonna make this guy green. The grass is greener. on the other side. Alright. But I think the grass is green everywhere. Green is just a subjective thing. It's totally abstract, but not true. It's not practical. The grass is just green. If you give it fertilizers, wherever it is, it becomes as green as possible. Or should I say as green as I don't know, as green as green. But if you don't give it what it asks, which is nutrients, then it won't be green. It will be yellowish to show that it's malnourished. Okay. Enough of the nonsense. So we're comparing these two eventually. Again, this and that, they are vertically opposite angles, right? Oh, these crayons are running away from me. I don't like what they're doing. So we know now that, oh right, that is vertically opposite that. Alright? Eventually we proved that this one equaled that one. So in the end, if you've proved two sets, the remainder will be, but if we've said this is parallel to that, these are certainly alternate angles. So we can now shade that little corner there. Say, yeah, we know. It will definitely be equal to this guy right there when we get to U, because you are alternating, or you are the remaining angles. So whether you've proved parallelity or not, it just doesn't change anything. So we can deal with that one easily. Now it says, hence calculate the length of GH. Okay, maybe let's cross that bridge when we get to it. Let's quickly get rid of the easy stuff. All right. Question 9. I mean, this question paper sounds very easy. It was as if they didn't want to ask anything here. I wonder. So easy. All right. This one is just as simple as 9.1 until the end. 9.1. Great. 9.1 says, give a reason why triangle DEG. Now, what is DEG? Sorry, is this blue triangle there over the pink triangle, so the outlined triangles. All right. So we're given a lot of angles. So here is just one mark. So triangle DEG is definitely similar to triangle EGF. We know that. Alright, what is the reason here? They are equiangular. I don't know what is the best way to say this, but I'm just going to write equiangular. Okay? Or you can use that side business. Alright. There's nothing really to say here. When they say one mark, you don't have to do a lot of work. Okay, not a problem. And then 9.2. I don't want to suffer here, so we just want to move. Calculate the length of GE. Now this is taken from the proportionality of those sides. So what can we say? We want to derive an equation such that we get GE squared, because we don't want a third side which we don't know. We only know two sides. So if we can get the side that is common to both, then it makes life very easy. And GE is common to both, so we know that the square is going to have to be on the GE. Alright, so it's up to us what we want to do, but I would rather start with the GE. Okay, so it's going to be GE over, remember the GE is of the, GE now is for the blue triangle. We're starting with that one. And then this side is opposite that angle there. That angle equaling that, so the side corresponding with GE on the pink triangle or red triangle is going to be GF. Okay, so GF equals, now we want the side that has a number, so it's DE on the blue triangle over the side that corresponds with DE equals that angle, that side is opposite that angle on the other one being equals to that F, and then the side opposite it is GE. GE. Alright, what is the reason there? These are the proportional sides of similar triangles. Great stuff. That is the best we can say. Then here we just cross multiply, and then we will have now, this implies now that GE squared equals DE times GF. Okay, easy stuff. Now we just substitute and then say, okay, now what was DE? DE was 45 units multiplied by, what is GF? It was 80 units. Alright, that's easy. Okay, this implies that GE squared implies that GE squared. Now we just use our lovely instrument called a calculator. 45 times 80 is 3,600. Alright, right. 3,600. And then we say, okay, we don't want GE squared, so whatever you do on the left hand side when you have an equation, you must do on the right hand side. And of course this is a length, so we forget about the negative value. So we can say this implies now that GE, but you have to express it at first. It's plus minus the square root of 3,600. So this is like the square root of 36, which is 6. So it's going to be 600, you know. I think so. What did I say? 600? No. It's going to be what? 60. Let's just see what the calculator says. Yeah, because we dropped the other 0. It's going to be 6 and then it dropped 1 0, so it's 60. So therefore GE equals 60 units. Alright, not a problem. That is easy. It's an answer. Okay, let's move a bit quicker. I'm starting to relax too much now and I'm losing my time. Okay. So what did we say? We said, okay, fine, if those two triangles are similar, their sides are in the same proportion, then we knew that we wanted to derive a GE squared on the other side because we only know two sides. And then there we are, we found that it is 60 units. So how many marks were there? 3 marks. So this is important, I feel, and then the correct substitution over there, and the answer should be enough. Alright, that is it. So we are good. And then 9.3. Now we have to prove similarity again. So in triangles, so here we're going to have to work, unfortunately, in triangles ADEH. Sorry, in triangle DEH, yeah, and triangle FGH. Right, let's just do this. Let's just do this as fast as possible. So, what do we know about these two triangles? Okay, we know first that this angle GED, what was the name? DEG. We know that DEG equals EGF. So you see, that's nice. Why do we know these things? They were given, right? Yeah. DEG was given. Was it? Yeah, ne? Was it given? What are we going to say about this one? They are part of the triangles that are similar. So they are corresponding sides, okay? Yeah, this is a bit silly. Maybe we should have expressed that. So we can say these are the corresponding sides in similar triangles, which is triangle, the very same triangles actually. DEG and triangle, same EGF above. Okay, this is a bit silly. Yeah, the way it looks is very silly, but it's fine, it works. So these two are equal because these are the corresponding sides in those similar triangles. Okay, fine. We didn't say it clearly, so that's why we have to say it now. Alright, 2, can say also, what do we know? We know now that from that small triangle, we know that DHE must also be equal to GHF. Okay, these are vertically opposite angles because those are the straight lines crossing each other. And then this sums up. This implies also that what are these angles now? These two. So we're going to say now this one is going to be EDH. EDH will also be equal to GFH. Alright. Why are they equal? These are the remaining angles. Alright, great stuff. Therefore, triangle DEH is similar to triangle FGH. Oops, rush. Angle. Alright, good. We are right where we want to be. Alright, yeah, that was a little bit silly, but it's working. So we just had to declare that DEG equals EGF because this was implied when these two, the first set was compared to be similar. It meant those angles were equal. Alright, and then we said, okay, fine, these ones are equal because they are vertically opposite angles, as you could see there. And then of course these ones become the remaining angles, even if we didn't state that these lines are parallel. But if you liked, you could easily say that those lines were parallel, and you can just say these are alternate angles. How you see it is fine. They're giving you as many options as possible so that you don't fail. And yet we now knew that these ones are the remaining angles when those two are equal, so the similarity was proven. So 3 marks. Maybe to state this because it was not quite clear, and to state that was quite significant. The remaining angles is not really important, but what is important is the last one. Okay. No problems. We've got the marks. So last question here. Hence calculate the length of GH. Okay, now it's a bridge we need to cross and cross well. 9.4. So I think we've spent an hour now on this, so we need to move. So 9.4, how are we going to calculate GH? Now we can look at these two triangles. We know that this side GH corresponds with HE. All right, great. And we know that this GE, we calculated it above. So if we want GH, we know that we're going to represent HE as GE minus GH, so that we just don't have the HE. So we can eliminate the HE that way. And we know that side, we know this side, so our lives are very easy. So all we have to choose is these sides and those sides to correspond. Nice and easy. Okay, so from this triangle here, we know we're going to use HE. Okay, great stuff. So we're going to say HE over, now HE is opposite that angle equals this angle on the other triangle, and the side opposite it is GH, which is what we want. Alright, maybe I should have started with that one. It's not a problem. How you started, it doesn't matter, because maths will always correct itself. Alright, now what else? We want that side, okay? So it's going to be the same as DE over, of course, the side corresponding with that one is GF. Okay. Again, the same story. These are the proportional sides in similar triangles. Alright. Maybe we can state which ones is triangle DEH and triangle FGH, because we had a lot of similarities there, so it becomes a bit difficult. But the other thing you can say, you just write this one in terms of these triangles. You can just say in triangle DEH and triangle FGH, and then you can say this. So I don't know why I didn't say that, because I always say it. But hey, I guess this is another way of showing those who won't like to do that and say, fine, we don't care where these are, but we're just going to state those triangles eventually, because this is also a comprehensive reasoning. Alright, not a problem. Maybe it's just a variety to some things, but I like order. Order, comrades, order. So here we just simply do this. We don't have to sweat here. So this implies now that HE times GF equals DE times GH. Alright. Now we know the value of DE, we know the value of GF, but we don't like the HE. But HE, because they make up the same line, GE, we can just say, but we know that GE equals GH plus HE, okay? This is just a straight line, okay? Just say C diagram if you like. I mean, you can just say GE is a straight line. I mean, even if it wasn't, but that whole length is made up of these two. Okay, so this implies now that we want HE, so HE is going to be GE minus GH. Alright, because we want to eliminate the HE from our expression. So this now therefore tells us that instead of HE we put this one. We know now that GE minus GH times GF equals DE times GH. Maybe I should have put those numbers already. Alright, not a problem, which implies now we can substitute GE. We found out that it was 60 units above, right? Yes. So we know now this is 60 minus GH times GF is 80, okay, equals and then here DE is 45 times GH. Okay, now we can see here we don't have a choice but to multiply everything. Yeah. Okay, this implies now we just put 80 into there. So 80 times 60, we get 4,800 minus 80 GH equals 45 GH, because I mean that's just what this is. Alright, so we can now say this also implies that we have 4,800 equals, we transpose the 80 GH to the 45 GH. So 80 plus 45 is 125 GH. That was a silly question, you know. And then now we divide by 125 throughout, so we know now that GH is going to be equal to 4,800 divided by 125. So this is now 38,4 units. That's the answer. So that is fine. It looks a bit silly, but yeah, math sometimes does not give you so much of an option, but as long as you know you followed the math correctly, you will not be in trouble. You will definitely not be in trouble. So it's 38,4. Oh, where's this paper now? Goodness. Alright, great, I found it. So let's review this quickly and say what did we do there. Alright, we said fine, we should have just stated that we're working in these two triangles, but it's fine. We just had to say HE over GH equals DE over GF. Why? These are the proportional sides in similar triangles. I just had to state them because I didn't state them nicely. If I did, I would have made my life easy. Anyway, we just had to do that ratio and proportion cross multiply, and then we get this. But we realized this is going to be a challenge. So we had to derive an expression to eliminate the HE. We knew that GE included GH plus HE. So we just had to make this one the subject of the formula such that GH, which is what we want, can represent HE. And this is where we ended up, okay? Just did the correct substitution there, and like terms, brought them closer. Then we got 125 GH, then we divide both sides. We get 38.4 units. So this was also 3 marks. I think we took a bit longer here, but I think that statement is good, and I think this one is good, and the answer, because I mean the rest is just pure maths. Alright, that sums up the 10 marks in this question. Great, I hope you liked it, and yes, that one moves away. Okay, now we have a proof of a theorem here. Alright, now this theorem, we proved it before. I don't know if it is worth it to do it again, but you know what, it never hurts to keep practicing. For your benefit, I will do it again. Alright, so the construction here you need to make, I don't know why this thing likes to not come from the corner. It's frustrating me. Okay, so the construction you need to do there, okay, let's just use letter P today, not T. It will sound a little less mysterious if we do that. So we divide this one into 1 and 2, and then this is 2 and 1 also, and that's all. That's all you do. But all you're going to notice is that this becomes an isosceles triangle as well as that, because these are all radii or radii. So which simply tells you now that these angles are equal. Alright, and these ones too are equal. Okay, and you represent this angle. So what you're going to have to do now is to represent this exterior angle okay, that O1, you're going to represent it for this triangle over there, and then you're going to also look at this side as well and say this is yet another exterior angle that is worth looking at. Alright, so that exterior angle belongs where? For this triangle. And then you know that these two angles make up BOC. So when you add them together in terms of those triangles, you have proven the theorem. Okay. So let's just do it nicely and not be lazy. I know I'm lazy right now. Let's just do it. Question 10. Great. Question 10. We know what we are given. Oh, it's 10.1 by the way. 10.1. We are given circle with center O. Okay. With A, B, and C drawn on the circle. Alright, so you state everything they gave you, and then you're going to say to prove. Oh, that's wrong. See, now I'm losing focus a bit. Now to prove, what is there to prove? It's to prove that BOC equals twice the angle A. That's the one. And then you say construction. What is the construction? You just say draw diameter AOP, and you show it on the diagram. So we drew it. It's a diameter, that line. Alright, and then we're going to say proof. Great stuff. What is the proof? Now we focus on two triangles, the brown one and the blue one. Okay, so we can say in triangle, we name it, we can say AOB. We're going to start there. First. Sometimes you can combine them if you like. You see, there's always many ways of killing a cat, so you don't have to stick to one simple way. Okay, I don't know what I'm doing now. Okay, you first start by saying OA equals OB. Alright, why is this story? These are radii or radii. This implies, you see, when you state something, it means something. What does it imply? It implies that angle A2 equals angle B. Again, what is this? Angles opposite equal sides. Great. Good reasoning there. So this makes that triangle an isosceles triangle. we're happy. We can say also, what do we know? Now, looking at this triangle, we know that angle O2, because I put a 2 here, angle O2 equals angle A2 plus angle B. What is this? It's an exterior angle of a triangle. Again, we know we are talking about triangle AOBC. Stating it makes life very easy. Now, what does this imply? It implies that now O2 equals twice angle A2, because we said these two angles are equal, but now we're interested in the A because B is just a means to an end. Alright, great. So we are done so far. Okay, let's say therefore instead of this implies. Therefore, okay, we can say now in triangle, maybe we can say likewise. Yeah, I didn't think about it. Likewise in triangle. Now what is this one? Is AOC. Okay, so when we state these triangles, we make our lives very easy. Okay, let's rush with this one. We know that now OC equals OA. Again, these are ready or not. Okay, this implies now that angle A1 equals angle C. Again, these are angles opposite equal sides. Great stuff. Okay, now what are we going to say? We can say, however, lovely words. We know that O1, which is that exterior angle there, equals angle A1 plus angle C. What is the story? It's an exterior angle of a triangle, which is that triangle we're talking about. Therefore, we know now that O1 equals twice angle A1. Again, we are trying to eliminate C. It was just a means to an end. All we wanted was to be able to double that angle. We can say, all right. Is there anything else we want to say here? We will say, but what? We know that BOC, as they put it, equals O1 plus O2. Okay, there's nothing else to say there. There's no reasoning. You can just say C diagram, because some people don't believe what others are saying even when it's evident. So you just always have to, here's the reason. Because they always ask you, do you have proof? When you go and open a case in the police station, they'll be asking you, do you have evidence? Like, come on, man. Why would I come report anything if I have to bring in the evidence? Because, it's not going to be of any use. They'll just say, this is weak evidence. But when will it be strong? When someone builds up a case around it. But again, they'll have to be bold to make those conclusions. No one is going to make those conclusions for them. But hey, that's just the world we live in, of evidence. Everything must be evident. Even when it is evident, it's not enough. Okay, that's fine. O1 equals 2A1 plus angle twice angle A2. Alright, great. Because that's how it went. So we just substituted, of course. This now says, okay, let's take a common factor 2 out. We remain with A1 plus A2. Alright, so what is A1 plus A2 is angle A, because they didn't say it. Okay, so this now becomes twice angle A. Okay, they didn't want to say it, in other words, so you can just put it back here and say, therefore, BOC is twice angle A. Sometimes the way these things are named is a bit silly. So it creates a bit of an uncomfortable situation for someone who feels things should always be linked nicely. They don't always link nicely. Again, when you prove a theorem, you start by saying what is given, as it is given to you, and then you say what is there to prove, and then you say what is the construction that you need to make. Then how you go around this is the way you know how. So we started in triangle AOB, and then of course we knew that we wanted to derive an expression in terms of the exterior angle of that triangle. Then we derived yet another expression in another triangle in terms of the exterior angle of a triangle. Then to link those two together and then end up with that mathematical manipulation, which holds very true indeed. So that was 5 marks. Again, I always feel the construction makes light work of the situation, and I will give a mark for that. I will give a mark for that, and I will give a mark for the last one. So it's 1, 2, 3, 4. I don't know where's the other ones. I'm sorry guys, it's just so difficult. But I think the correct substitution here makes some kind of logical sense, because I mean all these other reasons are very important, but what do you say? Difficult, you know. It's very difficult. Yep, okay. That's alright. We have 5 marks, and it's just as easy as that. So we are saying now, alright, we have run the marathon. Let's wrap it up quickly. Let's just wrap it up very quickly. Okay, nicely. 10.2. We are told in the diagram the circle with center F is shown. Okay, there's the center. Okay, let's just make sure it's obvious. Alright, doesn't show anything, and I hate that. Okay, it's drawn points A, B, C, and D lie in the circle. So meaning, once they say they lie in the circle, they are concyclic. If you were to join this into a quadrilateral, it would be a cyclic quad. But now that there isn't any joining of anything into a quad, but it means these points are concyclic. They are circling around, okay? Chords AC and BD, intersect at E such that EC, the Eastern Cape. Wow, my province is so lovely. It's showing up everywhere, okay? EC equals ED, okay? If this is the case, we know from that statement that, well, this angle must be equal to that angle. These are sides opposite. These are angles opposite equal sides. But I still love to say base angles of an isosceles. And then again, we know if these points are concyclic, that angle there also, let's just highlight it nicely on the arrow. That angle equals this angle. These are angles in the same segment subtended by the chord AD. Alright. And if this angle equals to this angle, what other story can we say? We can see that this arc BC, because there's no chord, so we say arc BC subtends what? A1 plus A2. So this angle also equals that one. Why? These are angles subtended by the same arc BC. Okay. And if this is the case, we know these ones are all equal to x. Therefore, we have an isosceles triangle there. So we have a nice isosceles right here, because now this is yet another big isosceles triangle. So folks, get comfortable with interpreting this. Okay, now they love the word data. Is it data or data? Whatever. So be very happy when you are given data to work things out, because it seems everyone wants the data. If you're saying the treatment works and there's no data to back that up, they'll be like, nah, you're bluffing. Show us the data. Yeah, anyway, data, people. Look at the data. Alright, so we have that. So I'm gonna do this one yellow. You know my yellow, man. My yellow color is superb. I love it. I love that one. It's for jealous, a thing I don't have. So you see we have a yellow isosceles, because now we know that now, man, if this is x and that is x, this triangle is isosceles too. Yes. You see, this is great stuff. And what else do we know? We also know that this angle right here, now we're just going to be very silly now and just go, this is a complicated diagram, so we just have to simplify it as best as we can. Now, do you see something here? This tells us that these two angles must be equal. Why? They are vertically opposite angles. When two straight lines cut each other or cross each other, they create this vertically opposite angle situation that equals each other. Alright, okay, good. Now let's hear what is the story again. Chords AC, okay, fine. We interpret it to that level. It looks okay. Oh, did I forget? Okay, let's leave this one for now. Let's leave this one for now. Let's just have a look at this. I want to highlight the center. It's very important to highlight the center, because there's yet another isosceles right here. There's just a diagram of isosceles triangles here. So take a bit of time, guys, when you're doing this, because you want to go at the speed of light, but don't be too excited, because you might find yourself making silly mistakes. Sometimes a little fear causes you to be meticulous, so do not eliminate fear and enjoy comfort too much. Comfort can be a big problem. But be in a position to say safely, I can do this. It can only take a horrible mistake. So you see, this one also is a situation where we have an isosceles. Why? These are radii or radii. So again, I swear to God, this is like, look at this thing now. Now we know here, let's just shade this one brown, because I like these colors to be clearly distinct. So now we know that this angle and that one are equal. So those two and this one, because now there's two angles over there, 2 and 3, they are equal to this one. So I think we've simplified our diagram pretty much. Okay, let's look what is the rest of the story here. The story now says to us, okay, K is the midpoint. K, midpoint of chord BD. So if K is a midpoint, so unfortunately we cannot portray that, but what we know is that this is 90 degrees. So we have 90 degrees on either side. Why? A line drawn from center to the midpoint of a chord is perpendicular to the chord. That is theorem 1. Alright, that's fine. FK, AB, CD, AF, FE, and FD are drawn. I'm not even interested in showing where they are, because I already stole them anyway. Let angle B equals X. Okay, so fine. We know now that this is X, this is X, that is X, making that an isosceles triangle. This is an isosceles triangle, this is another isosceles triangle. So this whole situation is just complicated. That angle equals that, vertically opposite angles. The other thing that we can note is that this angle is twice that angle. angle at center is twice angle at circumference for the same arc or chord. Or you can choose differently and say that angle and that angle is half this angle, or this angle is twice that angle. Angle at center, twice angle at circumference. But we know these two are equal because they're in the same segment. So whether you choose this one or you choose that one, it's not a problem. Okay, good. I think that is the best we can extract at this point. I mean, everything else is just overwhelming. So we're going to make mistakes now if we try too hard. Let's just let the questions lead us to Jerusalem. Determine with reasons the size of each of the following in terms of x. Okay, F1 and C. F1 is twice x. Angle at center is equal to twice the angle at circumference, whether this or that. Angle C, okay, maybe we'll just use B directly, so that angle C, we know now that we can either do this or we say that and that are equal. They're in the same segment. Great. We can do that. Prove with reasons that AFED is a cyclic quadrilateral. 4 marks. Cool. Yeah, okay. If we can prove that angles in the same segment, now that we know the size of that one, if we can prove this is 2x as well, which it is indeed. Why? Because it's an exterior angle. You see, E3, sorry, is an exterior angle of this yellow triangle, right? Or it's an exterior angle of this big triangle, brown one, whichever you want to look at. That is x, so x plus x gives you 2x, or use this one, it's the closest. X and x, so an exterior angle of a triangle equals to the sum of the two opposite interior angles, and don't use that adjacent as yet. Alright, so this is 2x. So if this is 2x and that is 2x, this becomes a cyclic quad. Angles in the same segment, subtended by the same chord AD, are now equal. So it's the converse of that theorem. Great, we can do that. Prove with reasons that F3 equals x. Okay, F3 equals x. Yeah, that's going to be a bit of work. Let's jump it. It's quite a nightmare. We'll see how we connect that. If area of triangle AEB, so this brown one, equals 6,25 times the area of DEC, the deck of cards, okay, calculate AE over ED. AE over ED, okay. So these ones are in proportion, so it's fine, but we have to use the areas. Okay, not a problem. We can use the area, which is not an issue, so we can deal with that pretty easily. Okay, fine. Let's start working and see where we get stuck. Then we take a breather and look at it more closely. So, question 10 continued. All right. Question 10 continued. So we have 10.2 this time. So we have 10.2.1. And this is divided into A and B. So A, what do they want? F1. So F1 is the angle at center, is equal to twice the angle at circumference, because these are both subtended by AD, same chord or arc. So we know F1 equals twice angle B, right? The reason is angle at center equals 2 times angle at circumference. So I don't like to write words, sometimes I just use symbols. At circle or circumference, good. Sometimes those short methods, when you are tired, they come into a good effect. Equals 2x, because B was x. Therefore F1 equals 2x. That is the answer. That is the answer. So we were looking at 2 marks. So that's the story. 2 marks there. Okay. Good. So we knew that from the diagram, that is the angle at center equals twice the angle at circumference. So that was x, so it's going to be 2x. All right. And don't forget what you have solved. Sometimes it's wonderful to just plug it in, but sometimes the diagram is too small to accommodate this. So it's just keep it in mind. All right. Angle C, they are in the same segment, so it's lovely. Do you see how easy now? It doesn't become such a painful. Angle C equals angle B. These are angles in the same segment. Okay, subtended by chord AB, was it? Yeah, AD, sorry. Great stuff. So therefore angle C equals x. That is the answer. All right. We're doing fine. So we said fine, angle C equals angle B. These are angles in the same segment. Remember that bow tie situation on AD? Great stuff. So angles in the same segment are equal, and therefore C equals x. So statement and the reason, and the answer, 2 marks. Great. Now we go to 10.2.2. All right. Now what does it say? Prove with reasons that AFED is a cyclic quadrilateral. And then we knew our key to this was this guy right here. This guy right there. Right. Okay, so let's just choose the yellow triangle for reference here, because it makes life easy. Okay, we can say now in triangle DEC, the deck of cards. I like to do these things because they make my life easy. So we know that EC, Eastern Cape, my lovely province, equals ED, Education Department, which is another lovely thing in the country. Okay, so now these two guys are equal. That was given. So I always like to set the mood right. We can say this implies, why? Now we're talking about this triangle. It tells us now that angle C equals angle D3. But use D3 here because it's quite a complex situation here. It's not a standalone angle. So those little numbers, they make life very easy. So what are these? These are angles opposite equal sides. I can see also that this reason has become quite popular in these questions. You hardly will have a situation where you can't use it. It seems to be present everywhere. Alright, so we know why we're doing this, okay? We know why we're doing this. So this equals x, right? Yeah, maybe we should have said that, because we know C equals x. Okay, great. Then we can say but what? E4, angle E4 equals angle what? Angle C plus angle D3. And then what is the story there? This is an exterior angle of a triangle, and we no longer have to say because we stated exactly where we were working on. Alright, this therefore tells us now E4, which is our interest by the way, equals x plus x, which is 2x. Now are you looking at this? Now that we have started in this triangle, now we know for a fact that E3 did I say E4? My lord, excuse me. Sorry guys. This is supposed to be E3. You see, when you're too excited, you make mistakes. So this is E3. It's not E4, E3, okay? Now this angle, we said we wanted to look at this triangle AFED. Now these are angles in the same segment, so we knew that this was 2x from above, and then we know now this one is 2x. So what can we conclude here? We can now say therefore angle F1 equals angle E3. Okay, so we can say each equals 2x. There's nothing else to say. But now if these two angles are equal, we can now conclude that AFED is a cyclic quad. Alright, of course, this is now converse of angles in the same segment. Great stuff. So see, life is very nice when you know how to plan. So you must be a good planner when you're a mathematician. Don't be clumsy and careless, and focus on just getting the answers. Let your work be smooth. Let it be clean. You know? Because sooner or later you'll become somebody. You need to be able to design something very good to look at. Something that is solid and it's together. Okay, so we said, okay, let's be organized. We said in triangle DEC, because we knew we were interested in calculating the value of E3, okay, so that we can say, okay, now this is where we are. Because I don't find any other easy way to crack this one, honestly speaking. It seems like this is pretty much the only way so far that I can see will work. But other ways may work, but they can be quite challenging. So the quickest way is the best way. Alright. Then we said, oh fine, we were given that EC, the Eastern Cape, equaled the education department. So Eastern Cape and education, but it's a different story. The failure rate in my province is shocking. But hey, the mathematics we're doing today is suggesting otherwise. Okay, C equals D3, which equaled x because we knew that angle C was x. These are angles now opposite equal sides, which we are talking about. And then we said, but E3 was an exterior angle of this yellow triangle. You could easily have chosen that one as well. But if you chose that one, you would have to first link D3 with A1 plus 2 and say it is equals to x, so that you can prove that these angles are equal before you do that. Okay, so I wanted the easiest, alright, something that was given to use it as a means to an end. Okay, and then we went and said, okay, fine, that is an exterior angle of a triangle, so it was x plus x, 2x. Now we said, these two, they look alike, and they are now in the same segment in that new situation. This proves that this is a cyclic quad. So 4 marks. Okay. So sometimes I prefer to start from the bottom. This is good, alright? And this is good. It's key. Okay. It's very key. And I think that is key. Okay, that is key. And now if we are recognizing this one, there's no need to mark it here. So I think to state those angles over there is fine. So this is the 4 marks. But remember, this is arbitrary, guys. I'm just showing you where to not make mistakes of losing marks, but the marks can be distributed in any way they see better. So it's not really a standard way of marking. It's just my arbitrary system of marking. Alright. Great stuff. We are happy with that one, and we're saying thank you very much. You have been very good to us. So Now here's a big hit, 6 marks. Prove with reasons that F3, yay, I'm scared of this one. Prove that F3, now can you see where that F3 is? Yeah, Lord. Okay, let's just shade this guy yellow as well, like completely yellow now. I think I love the jealous story behind the yellow color. Yellow for jealous. Alright, now eventually this is going to drive us there, and I think this 90 degrees comes into the 4, so it tells us we're gonna do this by calculation. There's no way we're gonna find another method here. Unfortunately, somewhere, somehow, a calculation is coming, so get ready to do some calculation. Some things you can just reason them out, but here we are forced to think of a calculation. So this is now 10.2.3. Okay, fine. Let's see, what can we do in this triangle? Now, we have to link this triangle with something we know. And we know for a fact that if this is a cyclic quad, this being a straight line, that E1 over there is an exterior angle of this cyclic quad. And we know this is 2x, so we need to use x to get to that triangle. So if this is 2x and this is an isosceles triangle, then we need to calculate this angle as a whole, meaning we need to calculate this brown angle over there. And if we calculate that brown angle, it must be equal to this angle E1 over here, because this is now telling us that, fine, this is a cyclic quad, so the exterior angle of a cyclic quad must be equal to the opposite interior angle of a cyclic quad. And if that's the case, you can almost see, if they ever asked you, hence determine whether AD is parallel to FE, they're definitely, okay, they are not parallel. Okay, forget about it. I imagined that this was going there, it was not, so forget it. Okay, just forget I wanted to say anything. So you can see that the first link here is to determine this angle, because this angle leads us there in terms of x, and we have 90 degrees there, and then we'll have this one in terms of x. Then we can calculate that from 3 angles of a triangle, and let's see if it doesn't give us what we want. So these are now the hard questions. I mean, these questions have been very easy, but now they decided they're cutting the cord. Okay, yeah, I gotta scream and shout this time for yourself. All right, so let's start in that triangle AFD or ADF. So AFD. Yo, what am I doing now? In triangle AFD, we want to start there, because this is a means to an end. It's not an end in itself. So we know, we start off nicely and say, nah man, we are going to take a chilled approach. AF equals FD. These are radii. Okay, now what does this imply? It implies now that A2 plus 3, because this is a corner angle of that green triangle. So now we're going to say, let's just say F, let's just call it FAD instead. FAD equals D1. At least that one we can safely use just that number. The problem here is that there's 2 numbers. I don't like these 2 numbers here. Okay, these are angles opposite equal sides. Okay, great. So angles opposite equal sides. See, this rule or this reasoning is forever in our face. So what does this imply? This also implies now that those angles all together must be equals to 180 degrees, and our target is to use this one because it drives us across into that yellow triangle. So now we can safely say now FAD, which is our interest guy, plus D1 plus f1, because f1 is part of that triangle, equals 180 degrees. The reason is sum of 3 angles of a triangle. And you see when you've stated what triangle you're talking about. Now these reasons don't fly in the sky like papers in the street. Okay, good. And then we say now this also implies now that FAD, okay, FAD, well, remember we said FAD equals D1. So we will eliminate the D1. We're going to say twice FAD plus angle F1, that was 2x, equals 180 degrees. So this is very nice. Therefore, it tells us now that we have FAD equals 180 degrees minus 2x all over 2. All right. What does this tell us? 180 divided by 2 is 90 degrees, minus 2x divided by 2 is just x. Perfect. So we are happy now because it drove us right into where we want to go. We're going to say but FAD equals, what is that angle there? It's E1. Again, this is an exterior angle of cyclic quad. Now state this one. It's important, but again, it's the only cyclic quad we ever proved in this diagram. But let's just state it, AFED. Okay. Yeah, there is the story. Okay, now therefore we know now that E1, which now is the key and the door into that yellow triangle, E1 is 90 degrees minus x. Woohoo! See, good planning guys. We can then say now therefore in triangle, now we're moving. FEK. Okay, there's a few things to say here also, but it's very interesting what is going on. Okay, let's not say therefore. This implies. Let's just say it implies. Okay, therefores are reserved for the end points. Okay, what are we going to say here? We know now that FK is perpendicular. Okay, let's just use an angle instead. Let's not say this one. Let's just say FKE equals 90 degrees. Okay, we want an angle now in terms of numbers. What is the reason? This is the line drawn, line from center to midpoint of a chord. Again, you see now these reasons are very difficult to complex at times because we're told K is the midpoint of BD. So this FK is drawn from the center F. So a line drawn from center to midpoint of the chord is perpendicular to the chord. So I think this is good enough to say. Someone will also remember that they told us that. We can't remind them everything. Hi. If nabo balibele nathi silibele ke thini khake siyaphupha ke ngo nyanzelekile siphuphe bafethu. We must dream. If they have forgotten, we have forgotten too. And we're just simply dreaming, but we're dreaming in a good way because we're dreaming a real situation. Alright. Great. Now this is key. Why? Because we know we want to use this 90 degrees to our advantage. Okay? And we have found that E1 is part of that triangle. So we're not gonna say anything now. We just wanted to establish the 90 degrees. We can say now, this implies now that angle FKE plus angle F, what was that? F3, our interest, plus angle E1, because these are all angles in that triangle, equals 180 degrees. Again, don't forget this reason. Sum of three angles of a triangle. Again, we don't have to state it because there it is. Again, this reason is forever in your face. Don't forget it. And this is the reason you get in standard 7, which is grade 9. Okay? So you see your grade 9 is forever in your face. So it's a very important step in your education steps. Alright? Great. We want F3. So this implies now that F3 plus this one is 90 degrees plus this guy. We found out on top that it was 90 degrees minus x. Okay? Equals 180 degrees. Great stuff. So what does this mean? It implies now that F3 plus 90 is 180 degrees minus x equals 180 degrees. Just a correct substitution there. So what is the story now? This implies now that F3 equals, now this is 180 degrees minus 180 degrees plus x. So a negative, when it crosses, it becomes positive. These guys fight and die, and then it's just x. Ooh, we got it. We got it. At last. That was a killer question, I swear. Sometimes to plan, you see what ukuyicacisa umzobo wakho, you know, kubeke ehleni. Awukahlala usanto yena drawing ya hao fela uyibona uri yaka mona uyibona hantle hore eban yetsa msebenzi ube bonolo. Ikwenzela umsebenzi lula kakhulu. Okay guys, that is what we can see here. So we just had to be very crafty here and said in triangle FEK, because now we have found, oh, I'm just jumping the ship now. Let's start where we started. So we started in triangle AFD. Why? AFD was an isosceles triangle for which we knew at least a side, and we knew this is an isosceles, so we can focus on that angle because it leads us to E1 which belongs in there, and with 90 degrees over there will help us determine F3 in terms of x. Okay, so we said fine, AF equals FD, these were radii, and therefore it told us that FAD, which is F3 and 2, equals D1. These are angles opposite equal sides, and then we just did the three angles of a triangle so that we eventually find FAD as 90 degrees minus x. And we said, hold on, FAD equals E1 because it's an exterior angle of cyclic quad AFED, which is something we just proved above. And this helped us now to determine that angle as 90 degrees minus x. And we said, fine, we're finally where we want to be now, our landing place. Now we said FKE is 90 degrees. We were given that K is the midpoint of AD, alright? And I mean BD. And a line drawn from center to the midpoint of a chord is perpendicular to that chord. That's Theorem 1 in grade 11. Then that worked in our hands because we just had to put everything nicely in terms of three angles of a triangle. And then we worked everything out by correct substitution of what we have found above. We then knew eventually that indeed F3 is x. So you see, these questions are very friendly because they just tell you where you're going so that you don't make a mistake. There are many other possibilities, so they want you to narrow it down to just x. Okay, that was 6 marks. I don't even know where to begin. It's such a big thing. It's such a big thing. So I think that is good enough. that these are equal, because it helps us a lot, and that is good to eventually find 1 in terms of x. And then this statement comes in, wonders, but we can't mark you for this again, it's already there. And then we say, okay, let's come here, and this is a powerful statement and a reason. It makes life easy. So we have 4 marks there, 1, 2, 3, 4, and then here we can do correct substitution, 5, and then we do the final answer, 6 marks. So that is cool. We got the 6 marks. Let's do the last run. So we have completed 2 hours. I thought we were going to be less than that, but I kind of relaxed a bit. So this thing is easy. This drawing became a bit complicated towards the end. Alright, last one says, if area of triangle AEB equals 6 times, oh, can't see what I'm reading. If area of AEB equals 6.25 times the area of the DEC, calculate AE over ED. Of course, these sides come from this, so we just need to look for them there. Alright, now this is the last one. So let's see if we're getting this total, or we're just going home crying. Alright. So this was quite long. Question 10.2 continued. So this is 10.2.4 now. This is 10.2.4. The last one. Alright, we're going to have to plan this. Now let's look at this area of triangle AEB. AEB. Okay? The good thing about triangle AEB is that we have not linked that angle and that. So we need to say something that links that to that, because it helps us to say this side equals this side. Then this gives us a very good choice for area to just use the area rule here, because we don't have a perpendicular height, so we can't use a perpendicular height. We simply are stuck with the area rule here. Now we need to choose angles that are equal so that the signs cancel each other out. So one can choose those, but the problem is that you're going to have AB, which you don't know what it looks like in terms of DC, so it's not very good to choose those. We want some things that are going to eliminate, such that we remain with only AE and ED. So my best choice is to choose these sides because they are equal. We're going to have squares on each, and that side and that they are equal. Then knowing that E4 equals that E1 and 2, we don't even care what size they are. They will cancel each other, they are signs. And then we'll have squares on the other side, so we'll be able to represent this ratio nicely. Alright, so let's start saying things now. Let's make this triangle an isosceles first, because we know that one is an isosceles already. So let's make this one an isosceles, number 1. Okay, so we're going to say fine. First and foremost, we're going to say now angle D3, okay. Let's just say, we just want to start here and say angle D3, yeah, angle D3 equals angle B equals X, okay? What is the story there? It's proved above. So it's so nice when you've done some work, so you just quickly refer to that. And then you can say, but why? We know that D3 equals angle, now let's just give it a nice name, BAE, because there's 2 angles in there. So we can say BAE. Okay, what is the story? These are angles in the same segment subtended by arc BC. Okay, so these are now angles in the same segment subtended by arc BC. Okay, that's the reason there, because these angles, that 1 and 2, they're subtended by arc BC as well as that angle D3. Okay, great stuff. And what did we want to say? We wanted to say, therefore, angle B equals angle BAE. Okay, now we don't really have to explain why, because each equals D3. It's as simple as that. Okay, let's just say each equals angle D3. Great stuff. Now what can we conclude? We can conclude, therefore, what we're interested in, these are the sides. Now we're interested in saying, fine, we can now safely say BE equals AE. Okay, now what is this? These are sides opposite equal angles, or converse of angles opposite equal sides, if you will. In fact, I forgot here, I should say in triangle. In triangle, let's say ABE and triangle DEC. That is the opening statement. I don't know why I forgot that. It's so powerful because it solves a lot of pain for us. So you start by naming these triangles that you're going to be working with, but you're starting broadly for each. So all we wanted to prove was that these two sides are equal so that we can eliminate stuff. Now we are ready to do an elimination process, because there's nothing we can say here that makes any sense here. So we are done. We are done because we just wanted to do this one as an isosceles. Okay. So what we can say? We can say now this implies, they said area of triangle AEB. Okay, we can say now, therefore, we're going to represent this one. So we can say, therefore, area of triangle AEB equals 6,25 times area of triangle DEC. Okay, that is given. That was given information. And then this implies now we're going to use the area rule. So remember, the area rule chooses an angle that is included in two sides, and these two sides we know they are equal, so we can interchange them, so it comes into good effect. So we know now that it's going to be half the sum of the two sides which are forming that angle, so the adjacent sides. So it's going to be AE times BE, alright, times sine of what angle? Angle AEB, okay, because it is that angle that is included by those two sides. This is just going to be a bit longish. This equals 6,25 times the area of that DEC is going to be half. Again, we want an angle that is included by those two equal sides, which is E4. So we're going to say now we are fine. It's going to be half of ED, which is the guy they told us about, ED times the Eastern Cape. So is the Department of Education this time, multiplied by the province, so that the province can be educated, you know. Good. And times the sine of E4. I'm just going to choose E4 for this one. Alright, it's quite a long, ugly expression over there. Not a problem. So we just simply expressed these in terms of the stories above. Okay. But now what can we see here? This implies that we have half. Now look, we said AE equals BE. So now this is the same as AE squared. Why? Because AE is part of the answer. So we just simply say fine. We know now that AE equals BE. So this is the same as AE squared sine of AEB equals, so we're just simplifying now, 6,25 times half times, now look, ED, we were told here, ED equals EC. So what is in there? It's ED. So we just eliminate the EC and say, okay, fine, now we know that everyone is educated. So it's ED squared times sine of E4. Alright. Great stuff. Now we know we can do a lot of things here. But what do we need to do? We need to do something. Something very wonderful. We're going to say but what, mister? We know that AEB equals E4 equals angle E4. Why? We said these are vertically opposite angles. Vertically opposite angles. Great. Okay, if they are vertically opposite angles, this now implies that we have here, now we will have now 1 over 2 AE, okay, squared sine AEB. Now remember, if you divide by that area throughout, because we want to isolate these sides over each other, so all we have to do there is just to say divide, just gonna quickly do this now, divide by half of ED squared times sine E4, alright, equals just the 6,25. Yeah, now I'm a bit tired. So half, it's half. These ones eat each other because these angles are equal. So sine of this is the same as sine of that. So you see, it's a bit silly, but it's good. So we now have AE squared over ED squared equals 6,25. Now, whatever you do on the right hand side, you do on the left hand side. Therefore, we know now AE over ED will equal the square root of that. That is, let's look in the calculator, but I think it's 2,5. Square root of 6,25. Yeah, it's 5 over 2. Yeah, that was not so easy. Look at how ugly my square root sign is here. That is that. Okay guys, that was a bit of work as well. So what did we have to say? We said in triangles ABE and DEC. Fine, we worked out our diagram, so it was easy for us to just formulate a way of now linking things up nicely. We said D3 equals B equals X. That was proved above. All we wanted to do was to say eventually, we know that D3 equals BAC of this lovely brown triangle. And then it did come out nicely that they are actually equal. Okay. And then of course the reason at first was angles in the same segment subtended by the same arc BC. And then we said B equals BAE, each equals to D3. And therefore we concluded that BE equals AE, because now this is an isosceles triangle. Alright, so now these are now sides opposite equal angles, the converse. Alright, we said now the area was given as this. We just wrote that statement as it was given because we were ready to do some work now. So unfortunately we did not have any right angles, so say half base times height. So we were forced now to use the area rule. So the area rule nicely gave us that, because now these two sides are equal, we just represented each in terms of the other. The same situation on the other side. but we realized that, well, these two angles that we chose, which is good because they were vertically opposite angles, those green angles. So we said, now fine, we know that AEB equals E4. These are vertically opposite angles. Now we knew for a fact that if we divide this into that, then there will be a lot of eliminations, leaving us AE squared over ED squared, and this, and then we knew we wanted AE over ED, which is that one. So 5 marks in the bag. Alright, let's see, how do we get these 5 marks? I think it is important to state this one. Very important, because the key is to get to say that, which is very important, I suppose. And I think for this representation, for each is a mark in terms of the area rule. And then again, to square these things nicely over here. Yeah. This is so rough now, man. Yeah, okay, it's fine. We can give a mark here instead, because I think this was also key. Then the rest of the elimination is not important, so we just jump for the answer and say 5 marks in the bag. And this is now the 24. Again, you can see they tied the knot at the end and said, yeah, we have to sweat for these ones. Alright guys, this now becomes, should I say, the last question paper on the Euclidean geometry. Now the next one, we need to move over to trigonometry, because there's a lot of work for you guys, so I'll try to get you there. So at the very end, when I've finished the trigonometry, which I think I'll do more or less the same series of question papers, at least 3, it sort of now adjusts everyone into that concept well. And once one grasps the concepts necessary to use, at least in a practical, examinable way, then one can safely say, all right, I am ready to now do the whole paper. So at the end of this series, we will then do a whole paper where I will include your statistics as well. Because I mean, I'm not against the statistics questions, but I find them to be too easy to really worry about. If you read your textbooks at this point in time and answer as many questions on them, they are the quickest and the easiest to deal with, and make sure you don't lose those early marks there. Well, what is important there is knowing grouped data and how to work with it. And when you're given an ogive, be able to interpret it or take grouped data into an ogive, and then be able to take a pooled data or a sample, and then you work out the mean, standard deviations, the equations of the least squares, regression line, whatever they call it. So those things are pretty simple, because it just tests how good you are with your calculator and how well you can interpret what your calculator provides for you. So we'll be able to look at a very nice question on that. So we will do a whole paper once we have done these little sections, so that everything is tied nicely and you are ready to hustle this. And then after that, we may probably have a look into some paper 1 related questions, which I find too easy and too extensive to teach. So it's best to just use question papers as well, and just go with it and see if it establishes any comfort in someone. And then once we've done those, then we may have a look at physical science, because I do feel there are certain areas that probably sharing my experiences with that and how I work things out there might actually help someone who has been missing that. But those who can see it, good luck already. Alright guys, I hope you enjoyed the video. Bye bye.